Hi, welcome back. So far we have focused on profiling and tools to monitor the execution time of different functions or different lines to understand where are the computational bottleneck. In this lecture, I want to describe a tool to monitor the memory usage. So slightly different from all the other profiling that we have been seeing so far. By the end of this lecture, we will be able to use the memory profiler module to monitor memory usage line by line in your code, pretty much as we did with the line profiler. We'll be able to analyze the profile information coming from memory profiler. We will be able to use the mprof tool to collect memory usage in time, so not line by line, but in time. And finally, we will use the very same tool mprof to visualize memory usage. So what is a memory profiler module? The memory profiler module, developed by Fabian Pedragosa and Philippe Gervais, measures memory usage on a line-by-line basis. Understanding the memory usage characteristics of our code allow us to ask two questions. First, could we use less RAM memory and save memory and be more performant by, for instance, rewriting this function to more efficiently? A second question is, can we use more RAM and save CPU cycle by caching? That means that instead of recalculating some stuff, we can save for later and reuse it. To install the memory profiler, we need to do a few simple steps. Keep in mind the memory profiler operates in a very similar way to line profile, but it runs far more slowly. So it does a more deep instrumentation of the code. For this reason, if we install the module called the PSUtil, that is highly recommended, the memory profiler will run faster. So before installing the memory profiler, is highly recommended to install the PSUtil module. So memory profiling might easily make your code 10 to 100 times slower. And in practice, we will use a memory profiler occasionally and line profile for CPU profiling more frequently. Even though line profiling is slow, it's not as slow as the memory profiler. To install it, we use the pip with the command line pip install memory profiler. And as I told you before, it's highly recommended to install the PSUtil before to improve the efficiency of the profiling. As I mentioned already, the memory profile takes much more time than simple CPU profiling. In many cases, we can run for a long time, but most of the time we need a quick and reasonable iteration to diagnose problems and hypothesize a solution. So the code that we have been used so far for the Julia set use a 1000 by 1000 grid. Remember that we gave argument to the function 1000. And the statistics for the memory profiling took about half an hour on my laptop. So it takes quite some time. So one thing that we can do is in some cases when memory profiling is taking several hours, we can just simply reduce the problem size. So scaling down the problem size. For this particular lecture, I scaled down from 1000 by 1000 grid, 1000 pixel by 1000 pixel to 100 by 100 grid. I just reduced the file to make the profiling of the memory more feasible to do quite quickly. There are other few points that we need to make when profiling memory. So we need to make aware how the memory allocation and how typically memory is allocated and deallocated. So the first part is that allocation is relatively expensive, so most of the code tend to allocate or over allocate at the very beginning of the simulation all the memory that is needed. So there is a typically set it up for the memory, ramp it up at the beginning, and then stays constant. The other point I want to make is about the garbage collector that is helping the allocating not use variables. So Garbage collection is not instantaneous, and so object might be unavailable, but still in the garbage collection pool for some time. So a few considerations to consider when looking at information about the memory profiling. So these few factors might be quite important when try to analyze the memory tracing. How the memory profiler is working. So the first thing we need to do, exactly like we did for the line profiler, is to tell the profiler which function we want to monitor line by line. As in for the line profiler, we simply add at profile decorator before the function that we need to do. So exactly like you did for the line profiler. Then what we are going to do is to call from the command line Python. We have here the name Julia set. This color is quite unfortunate on the black. So we call Python when the name, and then we do -m memory profiler. Right. So then we are going to have we know that it's going to be that at profiler that is telling the function to look at. In the line profiler, we use the kernel-prof script to get the statistic information, or to get the information about the profiling. So here we just do Python -m memory profiler and the name of the code that we want to memory profile. The memory profiler works is executed the code, and then after you executed the code, it profile all the information about the memory usage. As in the line profiler, we have information about the line, the memory usage line by line, and then the increment of memory usage occurrences. And as the line profiler, we have the line occurrences. As you can see, the increase of the memory is slightly here at the beginning, and then it stays basically constant. So memory profiler also has a very interesting, very important utility called mprof. Mprof is used to sample the memory usage as a first step, and also can be used to visualize the information that we got from the sample. The major difference between the memory profiler that we saw in the previous slides and the mprof is that mprof samples time by time. So we lose the information about the line, but we have a cursor information about what happens during the time. For this reason, the mprof is way lighter in terms of computational cost than the memory profiler we saw in the previous slides. So it barely impacts the runtime of the code. The first step to use mprof is actually to collect the memory statistics. So we just gather the statistic. To do that, we do Python -m mprof, and then we put the keyword run and the name of the code. So this line, what it's going to do is to profile by sampling time by time the memory usage of our code. The output of this command here is going to be a .dat file with all the information from our memory usage profile. Now, the next step, what we're going to do, we want to visualize. We take the output file that is generated by -m mprof run, and we visualize it still using mprof. In this case, the command is Python -m mprof plot instead of run. Right, so here we had run. Here now we have a plot, and then we need to look for the name of the file that has collected all the information about the memory usage. So here you have just a first example. The first thing is to collect information about the memory usage. You see that it is sampling memory every 1/10 of the second, and then our code is is running. Then I just do like an ls to check the name of the file, and then I run python -m mprof plot. This time I want to visualize it, and then I recover the name of the files with the memories usage information. When I do that, I get this nice plot that has different information. On the x-axis, we have the time. In this case, we do profiling by time and not line by line. On the y-axis, we have the memory usage in megabyte. You see, there is a phase at the beginning that is ramped up around 100 megabyte, and then there is a phase that incrementally goes up until the end of the simulation. So let's look at some more information, right? So we have on the black lines, we have the information about memory usage. We also see that there are some brackets here, here, and here. What are these brackets? Well, the two functions that we are unprofiled on this run are the calc pure Python and calculate z serial pure Python. So these brackets, what they do, they show where the time this function enters, right? So when they start, we have this bracket, and when they end, we have this other bracket. So in this case, this calc pure Python started here around at this time, and calculate z serial pure Python started this time. That allows to tell that basically most of the memory allocation occurs in this calc pure Python. You remember where we have the allocation of the CS and the ZS list? That's the part where we are wrapped up. From this point on, then we have the loop for each by loop going through all the pixel and calculating the thresholds, the escaping condition. So we can see the steady increase in the RAM usage here and through all the execution of the function. One interesting part is that we can actually add to the profile information some timestamp, some annotation. We do that by using a context manager in Python. So here we have the function that we want to profile, and then we can create some labels, some timestamp. Here we do with profile.timestamp, so we have the timestamp, and then we create a label here, right? A label that we want to be visualized on our plot. We do for this particular part, so we want to monitor this part here, and then we want to monitor this part here. So we want to add some timestamp and a label to this part. One thing that just for pedagogical purposes, what we want to do is to add 1 second of sleeping where we put the process to sleep. So once we add this context, this label, the profile will add additional brackets that we created with these two lines, with adding by the timestamp. So here we have the create output list, that is this green line here, and you see that this is very fast, right? And there is no big things. Then we have a time slip, that is this 1 second here, and then what we did, we add one timestamp here when we start this for loop, to go through all the pixel, and this is going to add this red bracket here. As soon as it's finished, then you add another bracket here. So this part here is the part doing this profiling. To summarize this lecture, the memory profiler modules allow us to monitor memory usage line by line, as we did for the line profiler. Its usage is similar to the line profiler in the sense that we need the decorator to instrument the function that we target for performance analysis. Memory Profiler provide also the mprof tools to sample memory usage and to plot it and add some timestamps as labels. This is the last slides of this lecture, and talk to you soon.